Good morning, everyone. My name is Albert. As Chantima has shared, I'm actually the CFD and also the structure application engineer here in Cybernet, Malaysia. So, today I'll be presenting about the data center thermal management with digital twin, which is essentially the real-time kind of thermal monitoring. Okay, and the solutions that I'll be sharing here is on Ansys products. It's called Ansys Digital Twin. Okay, so here is the sort of the content that I'll be sharing in a sequential basis. So starting off with the overview of this data center and the typical thermal challenges. And then of course I will introduce about the digital twin solutions. Okay, and then after that, the main thing I'll be sharing is that basically when you talk about digital twin, what is the thing you need to do in order to set up that digital twin? Okay, so that will be the steps that I'll be sharing. Okay, and of course, throughout the presentations, if you have any questions, you can just write it down. And then towards the end of the presentations, we're going to have a Q&A sessions where you can ask, and then I will try my best to answer. Okay, so without further ado, let's start. So first thing first, I think data center, I think without me introducing, I think I'm pretty sure all of us know what it is. Okay, so basically it's like a house or a facility that has a large number of all these computers, okay, servers. So they are typically used to do data processing, data storing, and for other various applications like calculating your simulations, analysis, that type of thing. Okay, and of course, main thing nowadays, the hot topic would be the AI. Okay, so there's a lot of data centers which is mainly for the training, gathering the data and training the AI. Okay, that is why there's been a growing number of data centers all around the world. Okay, and with that comes with the typical thermal challenges as well. Okay, so I think some of you might not know. Basically, when you talk about data center, the typical data center system, or we call a server rack. Okay, so typically they're gonna have like this is the servers, and then with many stacks, multiple stacks of those computers, the RAM and the computing equipments. Okay, so and then it's gonna stack up together in the rack. Okay, and then essentially they're gonna connect it with the switches all the way to the core switches. And then, so these typical data center architectures. And of course, various components, from the computing equipment, power system, and cooling, which is from the air conditioning inside the room, and with other things as well. So, and of course, monitoring management. This is where you do the monitoring of this data center, I mean the room, because if it gets too hot, then it's gonna, affect the performance of your data center. So you will not want that. So typically you will have the sensor and all those things to monitor, right? So essentially the data center is a makeup of all these different components. And obviously the main thing here will be the data rack, the server rack. Will be your main, heat source, where because they are doing a lot of work on the data processing and for various other applications. So they are going to emit a lot of heat. Okay, so this is where the thermal issues arises, and you would, typically we would like to address them. Okay, and of course, as I mentioned earlier, there are, when you have all these stacks of data and I mean the server racks, all together in a very high density manner, right? Inside the room, you could imagine this is like a thermal imaging, the temperature imaging of the data center. So you can see that all these server rack that I mentioned about, when they're doing the work, they are 100% operating, they're going to emit a lot of heat. And that's why the red color, which is, indicated by the temperature. Okay, so, and of course, thermal management is very important for data center because, as I mentioned earlier, if you have all the data center up and running, they are going to emit a large amount of heat. Okay, and without a proper thermal management, like the airflow cooling through all these data server, it's going to accumulate heat and essentially causing overheat and ultimately maybe equipment failure or even at the risk of fire or smoke, all those things. Okay, so you will not want that in the data center, right? That's why that there are various key challenges that will arise with all this, high density of thermal, I mean the data center, like hotspot formations, the airflow management, the high power density. With that, you're gonna have the high cooling costs as well, and then thermal runaway, poor rack and servo placement, in efficient heat dissipations. All this could, contributes to the thermal management. That is why it's very important. You need to have a proper thermal management in the data center. Okay, so you could essentially, if you have a proper one, you could know how to properly place your data center, the server rack, and then properly place the cooling equipments. Okay, so you have the optimum airflow performance throughout the data center. Okay, so that's all from the data center side. Okay, and so you see all these thermal challenges, right? Of course, you could do simulation or analysis on the airflow to get the optimum, performance. But ultimately, where we are living right now, the data center could be very in a dynamic situations where sometimes your equipment could fail or the air con is not working, right? So this is all some scenarios that could happen. So if in that case, if it happens, like what will happen to your data center, right? Do you need to, turn on additional aircon, or what is the, the recon plan? Okay, so that is where the digital twin comes in. Okay, and just a introduction. Basically, you can think of a digital twin is like a virtual copy of your data center when it comes to digital twin for data center, right? So you have the digital twin, thermal digital twin. With that, it can gives you the real-time sort of uh, monitoring or the results on all these on your data center. Basically, you get to know the temperature, the airflow, or across the whole data center live. Okay, so with that, you get to come up with the predicting and preventions uh, solutions for that. Okay, so again, as I mentioned here, so digital twin is that, and with Ansys, we have our own basically Ansys digital twin solution. It's called Ansys Twin Builder. Okay, and of course with that comes with the AI as well. Okay, to do the predictive maintenance. Okay, essentially what we are doing is like you can imagine you have your real model, which is the data center, and then we are gonna create like a digital version of it, okay, on the machines, okay, and with this, we are gonna do a series of setup for the digital twin where we're gonna have the simulations done to train this model, essentially ROM, reduced order model, which you can gives you the calculations much quicker. So that's why you get to have the live simulate the live results. Okay, so you couple it with all that, and then essentially, with all this embedded software and your system, that forms your whole digital twin. Okay, where it gives you the real-time simulations, real-time temperature of your data center. Okay, so when it comes to digital twin, just an overview of the workflow. Okay, so since we are talking about data center, essentially there are just 3 steps. Okay, so first thing first, we need to create a raw model. But before that, we need to do, because this is the digital twin for data center. So in order to access all these different temperature and velocity flow field of your data center, basically the airflow performance in your data center, we are gonna have to have the data first, right? So to do that, basically we are relying on CFD. For those of you who don't know, which basically means the computational fluid dynamics, is the CFD simulations to solve all these things, so you get to know the temperature and the airflow inside the data center. Okay, so the first step is always you need to use this software CFD analysis to basically create the training data, right? So the training data basically is you get to run basically transient calculations like time variation of a temperature. Okay, you simulate, let's say the aircon, the room is been running for 10 minutes. What is the temperature profile or the velocity profile across these 10 minutes, right? So those data, as well as the steady state, which is not doesn't disregard the time effect, okay? But that is also essential for you to know what is the flow, field, and the temperature, Okay, so in this case, we're actually using the ice pack, okay, which I'm going to talk about later. Okay, this is just an overview. Then once you have all this training data, okay, from the simulations, you're gonna convert it into the we call it ROM, the reduced order model. Okay, so why we need this is because, as I mentioned, if you're using the CFD analysis, that cannot, because it takes time to solve all this, right? So which is not instant enough. But whereas digital twin for data center, we need the instantaneous live result. So that is why we need to have the conversion of this into the ROM, okay, where you could actually generate the result much faster, okay? So again, in this one, I'm going to talk more about later, but essentially there's always a transient and steady state kind of ROM model, which both are required in order to build a digital twin, okay? And lastly, once you have all these things, you're going to integrate the model into your own system, right? Deployment, whether that could be from, of course, Ansys itself using the Python to generate all the results, or you can use other third party as well. Okay, so without further ado, now I would like to just go through the steps in slightly more details. Okay, so first thing first is the preparation of this training data, as I mentioned. Okay, and this will be in the form of the CFD analysis. Okay, so the software I'll be using here is on Ansys IcePack, which is a very good for electronics cooling application or your data center as well. Okay, so you imagine this is your typical data center. Okay, you have the server rack, which I mentioned about. Okay, and the computation the air conditioning, the C rack. Okay, so and there's some power distribution unit which could emit heat as well. Okay, and then the grating is the raised floor setup. Okay, where there's some a small holes. I mean the mesh of net where the flow can go through. Okay, it's basically for the cold aisle management containment. Okay, so as I mentioned, you need to have this your data center model set up in the CFD. Okay, and then whereas you perform the calculation on that, whether it's transient or steady state, right? This is where you get the result from. On the temperature side, you get to know, okay, where is the high temperature, where is the cooler temperature, okay, with the colors. And obviously with that, you get to see, your airflow, whether the flow is smooth or not, or you will get stuck somewhere. Okay, this is for you to monitor and to see whether this placement of the C-rack is proper or not, or you need to do some relocations. Okay, so you basically simulate the heat, okay, the performance of this whole data center, and then from there, okay, you play around with all these different things. This is again from the ice pack, right? So again, typically you get to set your data center, what is the heat, what is the heat flow, okay, power distribution, what is the total power, okay, and then of course your C rack, what is the flow rate and the temperature and all those things, inlet, outlet. And grating, of course, this is, you can imagine it's like there's going to be some resistance whereas the flow goes through it, right? So you can set all those things as well, the resistant model. And then lastly, of course, there could be some points which is essential for you to monitor, right? Let's say certain spot is always gonna have a high dense of heat coming out. So you're gonna put some points on that to model it. Okay, so basically you set up those things and then you run the simulations and this is where you prepare the training data, okay, for the first step. Okay, you prepare the model and then you run different cases scenario to prepare all these different training data. Okay, and once you've done that, we move on to the next step, which is creating this reduced order model. Okay, so this is what we call ROM as well. So as I mentioned earlier, if you're doing this kind of simulations, it takes time, right? Iterations. I mean, it could be a few minutes, it could be an hours, depending on your architecture of the data center. Okay, and of course, we need to run transient manner as well, meaning we need to simulate the temperature or velocity changes across the time. Okay, so those will takes time to calculate, which is not instant enough to give you the live monitoring output. That is where the ROM comes in. Okay, and as I explained earlier, there are two types, right? I mean, in terms of simulations, One is like the with time, with respect to time, and then the other one is without time. Okay, so we actually, in terms of the digital twin for the data center, you really need to have both. Okay, so first, that's why I say ROM one. So first thing, you need to have this. Again, this is, I won't go too deep into that, but essentially for the transient with respect to time, we need to build like the ROM, which is called LPV. Okay, you can think of that as the linear variant, linear parameter varying ROM. Okay, where basically you need to simulate the dynamic behavior or this system, across the different, in a timely manner. Okay, so you can see this one. Let's say if you have parameter, it could be your server rack heat, or it could be the C rack, the heat, the volume flow. I mean the aircon flow. Okay, suddenly you turn it higher, or you turn it low, or you turn it off. Right. So that is more on the dynamic changes. Okay, with respect to time. Okay, so you, of course, you you simulate all those things. You convert it into the ROM. Various type of different parameter. Okay, different responses. Okay, usually this is often associated with the turning on and off certain C rack, or turning on and off certain server rack. Okay, because sometimes the server rack might not be 100% running, right? There could be a one rack which is off, and then the other rack which is on, or the different various type of configurations. So you can simulate all those things uh, in the ROM. Okay, essentially you have all those training data, you gather together, and then this is you build into this the ROM. Okay, so from there it's gonna be able to give you the prediction result faster. Okay, so just one example of this one is like you have your C rack, right? Various different flow rate, as I mentioned, different scenario, 3.6 kilogram per second, or 7.2, or 14.4. Okay, so this is your heat I mean the heat source for all the different rack, right? So you can see 8,000, 4,000. This one is just different heat configurations, right? So from there you get to have the response from this ROM to see all these different, I mean the different scenario, basically, essentially. Okay, so you calculate for this output of each things, integrate them to build this ROM. Okay, and scenario wise, you can think of it as like, okay, so if I'm on the C rack running 3.6, then you could get to see, okay, let's say in scenario one, all of them initially are running 4,000 watts, and then suddenly across certain time, I mean, you get you to do more intense work, for example, on the server rack one. So that is where the heat generation goes up, right? So this is like a dynamic changes. So you can simulate this scenario, and then scenario 2, 3, 4, as various different rack goes up. This zero, I mean server rack 2 goes up, or rack 3, or rack 4, or essentially a coupling combination of different rack going up together. Just all the scenario you could think of, okay, for your data center, okay, because for each different data center, they're gonna have their own configurations, okay, the possibility. So the idea here is basically you simulate different scenario of server rack, and then you build this all these different scenario together. Okay, then you get to build basically train this ROM, the reduced order model. Okay, like you see here for the C-Rack 3.6, I actually have a set of data, and then 7.2, I have a set of data. So basically you get to build this ROM. So later on, when it monitors it gets the feedback, or the input from the real-time data center, you'll be able to give you an estimate result in a very quick way. Okay, because you already trained them in this way. Okay. And of course, that is on the transient side, right? Where you need to simulate the dynamic changes, across the time. But we need to have like a static ROM. Okay, so in this case, we can think of it as like a steady state. Okay, this is more for us to gather, because this one mostly maybe is for the monitoring point. We get to see what is the temperature at the point, right? So you get to see the temperature value, okay, in the transient time, okay. But to see the overall flow field, I mean, the overall temperature profile or the velocity across the room. We will, and then to be able to do it fast enough to give you the result, we need to rely on this static ROM. Okay, basically you get they have their methodology to calculate. Basically, it's running simulations on the steady state, right? So you get to see different temperature profile or according different scenario, and then you combine them together. Okay, so that they can again gives you a very quick simulation result. Okay, enough for us to monitor the real time. Okay, again, here is just some scenario you could set up if you are doing the static ROM inside the ice pack. Okay, you get to build this static ROM together, and then where you play around with all this parameter, the CREP, the heat generations, all those things. Okay, for you to simulate the different scenario. So this is a convenient, the convenient toolkit we have inside icepack. But of course, within other software, as long as you run the CFD simulation, the idea is the same. You build all these different scenario, and then for this ROM, okay. Once we have that, essentially a overview will be like this one, right? You have the learning data from the CFD, and then you apply this to digital twin, the ROM, okay. So from this one, you have the steady transient from the LPV ROM, and then you have the static ROM, which is for the flow field and temperature field data. Okay, so you have these two different type of ROMs together from the icepack as the training data, and then later on, of course, once we have done this one, you need to validate first, right? You need to verify whether in comparison with your own 3D, whether this prediction is accurate or not. Okay, as usual, you can do this after you train them. Okay, like after you train them with your icepack training data, you can check with the ROM to predict, hey, if I'm running this scenario, oftentimes you try to run it with larger than the training data, then you back simulate again to validate whether this is accurate or not. Okay, and of course within the Ansys software itself, they can do this as well. The discrepancy between the 3D simulation and the ROM, you get to see whether the simulation data is close enough or not. And the rule of thumb, typically, because we are doing the real time monitoring, right? You don't really need to have like a super accurate kind of like less than 1%, because eventually you want to know, you need to have like a real time data monitoring and predictive maintenance. So usually the industry guideline is like normally is less than 10% across all different scenario. Then that digital twin model is considered is a good to go within the industry standard. Okay, so after you build all these things, right, like next thing would be to actually deploy. Okay, and the deployment is much easier. Like once you have all this data, basically you just match it together with your real twin. The sensor and all those things in the data center. Okay, so as I mentioned here, this is just the visualizations. Okay, so you deploy them to your data center. So essentially, what you get is this is like LPV ROM, the one that I mentioned above, the transient ROM. Okay, so now this is all giving the real time data according to the sensor you have in your data center. Okay, you see this is the power consumption and then the cooling. The CREP output. Okay, and then all these different temperature, top view or the side view, velocity, right? All these things is generated from the static ROM, as I mentioned. Okay, so basically, you get to do all these kind of different visualization you want. Here we are using the PyAnsys, right? So the Python, to plot all these things. This is not from the icepack, because from the simulation is their own simulation, but this is where the result output from the ROM. Okay, so we use those data to actually post-process it into a 3D visualization manner using PyVista in this case. So it's just a Python third-party visualization tool. Okay, but the idea is that you can customize however you want to see. Okay, any angle, any view, or any certain rack you want to put emphasis on. Okay, but the idea is that once you build all those things, you deploy, you get to see all these different results however you want. Okay, and the idea is like this one, you get to visualize it inside the digital twin, and then use the PyVista, couple them together. The result you can you can visualize them however you want. Okay, so again, this is that is all from the workflow, right? So lastly, basically, you do the monitoring. I mean, this whole thing is done basically. Then it's good to go. You can actually just let it run, and then from there you get to monitor your results. Okay, the real time. Okay, and essentially this is here just a few examples of the different scenario. Okay, for real time. Okay, so like in this case, you could see normally is like in a normal operation conditions, you can see based on the previous example, everything is, I mean, all these different heat rack is actually running at a steady, I mean, the 4,000 watts, okay? Nothing too unusual. It's all working properly, okay? Fixed flow rate and server heat generation total. Okay, so this is a normal in a normal operation manner, right? Okay, so here you can see that there's no temperature higher than any 10 degree. Okay, so later on, this is where you can see, okay, if I want to ramp up my all the servers, okay, for example, all the servers are operating at 100% capacity. So you get to see that on the time scale, essentially, as it goes from normal operation, suddenly if you in the real time, your data center, you actually ramps up all the server, then it's actually increase the heat output, right? So you get to see the changes here. And then from there, I hope just now you get to see the changes suddenly, as it jumps. Basically, you have the real-time data. This is the actually the real-time data of the monitoring point, along with all these different plot here. So you get to see like in the temperature overall it increase because as you use all the server to run, it's gonna emit all the different more heat. Okay, so you can see you can see the real-time changes as as any changes within the server happening. Then of course another cases could be when your cooling C-rack suddenly malfunctioning or it suddenly stops for whatever reason, right? So you get to see your basically suddenly your cooling ice drop. So from there, after unit cooling stops, you can see the average temperature suddenly already exceeds the, I mean, if you can see it, you can see the room temperature. Once the, what is it, the C-rack stops working, it goes up instantly. So you get to see those effect, and then how long is it basically. So that gives you, the enough idea or the insight for you to monitor and then do the precautious, prevention. Okay, so that is the idea of doing this kind of thermal digital twin with your data center. Okay, and if I would just summarize it in one slide, that would be this, right? Okay, as we talk about today, in data center, there's more and more data center. So of course, the cooling is very important. Okay, because if you have a proper, effective cooling data center, it not just help you to solve the thermal challenges, it helps you to save energy and which is ultimately equals to cost also, right? So instead of putting as many C-rack or anything everywhere, you get to do you get to identify where is the actual spot you need, okay, to do all these things. And then so you get the optimum placement of your data center, server rack and all these cooling equipments, okay, for your data center. And with that, you coupled it to the digital twin, which we mentioned about today. First of all, you build this training data, okay, using in this case we are using Ansys IcePack for these data center simulations. You simulate many different kind of scenarios, okay, for this to convert into the ROM. We have two. One is for static, okay, for the flow field and the temperature profile across the room. And then for the transient one in a data point, which is on the LPV ROM, okay, to this one. So once you have all these things, you validate them inside the Ansys Digital Twin Builder, and then eventually you do the deploy together with the PyVista, all these things for you to visualize all these different however you want. Okay, this as I mentioned, this is just another example. You get to see different data or in a meter manner or the graph, just however you want, because you are using Python to plot it. We have the data running inside the ROM, everything. So it's just up to the user how to you want to visualize it, to those data. Okay, to provide because each company or each user, they have their different requirements. So you get to build them very customized manner. Okay. Ultimately, once you have this one, you get to see the real-time visualization of this to identify the thermal issues. And then of course, if something comes up, right, you get to immediately see the instantaneous effect. Let's say, like I mentioned earlier, the C-rack suddenly stops working, and then you get to see the temperature increase. Okay. Or if that server rack, every rack is operating at the same time, then you get to see the effect of the overall temperature inside the room. Okay. So of course, with this, you get to have an improved airflow management, okay, for hotspots and essentially prevents overheating. Okay. So whenever it's operating, you get to have real-time insight of whether this is doing fine or not. Okay. And yeah, so basically that is all from my sessions today. I hope that gives you an idea on how it works when it comes to doing the digital twin for the data center. Okay, yeah. So I think, yeah, that concludes my sessions today here.